This is the notes for multi-step equations in distributive property. Okay, so we're setting one last step. So distribute means when I have groups outside my parentheses, we're going to multiply everything inside by that number that's on the outside. Okay, then we'll just keep solving like what we have been the last couple of days. Okay, so this is our very last step. Is this the most complex problem? We're building up 2's down here. We'll have all the steps in it. Our goal is just to distribute first. So 2 times x is 2x. 2 times 5 is 10. Make sure we keep that minus sign there in the middle. And we're setting it equal to 8. Okay, so if that balance beam helped you, we're going to keep going from there like we have the last couple of days. The opposite of minus 10 would be to add 10 to both sides. My goal was to get x by itself. So now that x is on one side by itself, and my numbers are on the other, my last step is to do the opposite of multiply, which is divide. So if I divide both sides by 2, I get to a solution of x equals 9. Okay, so notice from here on down, it's like what we've been doing this whole unit. The only new thing we're adding today is that distribute. So 2 times both things inside my parentheses. My check step, I go back to the very original. And all I do is I put 9 in there where I see x. Okay, so order of operations. 9 minus 5 would be 4. And 2 times 4 is 8. So we're good. Okay, so our goal in solving the equation was to undo those steps. Okay, so I could have divided by 2 on my very first step. That would also work out. Okay, but it gets a little more complicated over here when there's other things on both sides. So our goal is to distribute first. That method will always work. So I multiplied both things by 2. And then we solved like a normal equation. Alright, let's try our next one. So I have 6 groups of t and 6 groups of 2. So I draw those little arrows there as a reminder to myself. 6 times t is 6t. And we also have 6 groups of 2, so 6 times 2 is 12. My minus 7, notice, is outside that parentheses. So the minus 7 does not get multiplied by 6. I'm only multiplying what's directly inside my parentheses times 6. So then we're going to combine like terms. That's what we learned yesterday. So 12 minus 7 is 5. I'm able to do numbers with numbers, but my letters, 6t, should not be combined with my 5. Okay, so now we get to start doing stuff on both sides. We want to draw that balance beam. So I simplified this as much as I could. I distributed, took them both times 6 to get rid of my parentheses, and then I combined my like terms. So 12 and minus 7 were normal numbers, so I could put those two together. So now I don't have any more t's that I can combine or any other numbers on the other side as well. So we can start canceling things from both sides. Instead of adding 5, I'm going to go ahead and subtract 5. So I have 6t equals 18. And then instead of timesing by 6, I'm going to go ahead and divide by 6. So our answer is t equals 3. Okay, let's do one more check step over here. So I have 6 plus 2 minus 7 equals 23. A little bit so you can see it there. So when I put in my answer of 3, parentheses first, order of operations. So 6, 3 plus 2 is 5. 6 times 5 would come next, so it's just 30. And 30 minus 7, 23. Okay. On the test, we're not requiring you to show those check steps, but it's highly recommended that you at least take that 30 seconds to just mentally run through, put this back into the original problem, and make sure it works out. Okay, you should know you get 100% on this test before you turn it in, because I should be able to put it in and double check that it works every time. Okay. All right, now let's look at some special cases. I have 4 groups of m and 4 groups of 3. So 4 times m is 4m. 4 times 3 is 12, but be careful, there's a minus sign there. So I have 4m minus 12. I also have a minus 4m on my left side. Okay, so before I start trying to subtract things on both sides, is there anything I can combine? Well, yeah, my 4m and my minus 4m, now that's 0m, so those have canceled each other out. That's exactly what we looked at above when my m's cancel each other out, am I left with a true statement or not? Okay, so if I have 0 m's, does negative 12 equal 5? And that's no. Negative 12 could never equal 5. So my answer this time is no solution. Or you may see on my answer key, sometimes I'll put a 0 with a slash through it. Okay, those both mean the same thing. You can write out in words, or you can use my mathematical symbol there. Okay, but our goal is we distributed, so 4 times m and 4 times 3. But then my 4m and my minus 4 I'm already on the same side. So those, I didn't have any left. So if I have no variable, 12 does not equal 5, that's a no solution. Okay, there is no check step because you could put in any number and nothing's going to work. Or over here in our last one, we have 2 yellow plus 5 yellow. And then the most common error is people forget to take 5 times 6. But my parentheses over here, we had 5 yellow and 5 in groups of 6 to make 30. On the right hand side, 7y plus 30. That was my first step. I distributed 5 times y, 5 times 6. Then I need to combine my like terms, meaning I can put my yellow blocks that are on the same side here together. So 2y plus 5y is 7y. But again, I cannot combine that with a number plus 30. Okay, these are two separate things. Think of it like yellow and a number. I can't put those together. I can combine these 2 and 5 because they both had y's. My plus 30, those is going to stay separate. Copy down on the other side. So now I've simplified it as far as I can. I get rid of my parentheses. I combine my like terms. I can go ahead and draw that balance beam and start doing things on both sides. My goal is to get y on just one side. So if I canceled 7y on this side, well, the 7y canceled on that side as well. 7y and 7y are both 0y. Remember, we don't have to write that down. But what I'm left with is 30 equals 30. That is a true solution, right? 30 equals 30. So my yellow is actually all real numbers. I draw it with that capital R, or you can write all real numbers if you want. Or you could say infinite solution as well. Those all mean the same thing. Okay, so no matter how we look at it, after I get rid of my parentheses and I combine my like terms, I could have subtracted 30 on both sides and then done my 7y and 7y, but I would still be left with a true statement of 0 equals 0. Okay, so it just depends how far you go. If you subtract your variables first, that's why we typically do that, then I may not have to do anything with those numbers. Okay, so that's our big idea. We're getting rid of the parentheses first, then I combine my like terms, then I can subtract numbers from numbers, or in this case, letters from letters on opposite sides. And that very last step is if I just have a letter and just a number, then we can go ahead and divide. All right, let's go ahead and try 2 more. All right, we do have some negatives here, so just be careful when you're working with your negatives. I'm still distributing, so negative 2 times 2 would be negative 4x this time. And then I have a negative 2, but then I'm timesing it by a minus 3. So if I do keep, change already, or if you think of it, right, minus is the same as adding a negative. I'm doing negative 2 times negative 3, and I would get a positive 6. Okay, so again, I took negative 2 times 2 to get negative 4, and then negative 2 times 3 would make negative 6. But since I have that minus sign there, a minus and negative would turn into a positive 6. Okay, so either way you want to write it, we should end up with minus 4x, but then plus 6. We're saying that equal to negative 2. Okay, so my first step was I got rid of my parentheses. Second step, do I have anything that I can combine? No, I cannot put an x with a number, so I can't combine anything. These are on opposite sides, so I'm going to draw my balance beam. My goal is to get this x by itself, because there are no more x's on this side. So the opposite of adding 6 is to subtract 6 on both sides. I'm left with negative 4x equals negative 8. We're in the whole 2, and I'm going down 6 more, so I should end up down at negative 8. Okay, and I undid my addition with subtraction. Negative 4x equals negative 8. So instead of timesing, I'm going to divide by negative 4. and get x equals positive 2. Especially with this problem on your test, I would go back and do my check step. Okay, so over here to the side, we're going to go ahead and put 2 in here. So inside my parentheses, order of operations, 2 times 2 is 4. Then I can keep going to my parentheses. 4 minus 3 is 1. And then negative 2 with my parentheses means multiply. So negative 2 equals negative 2. Yes, this thing works. Okay, so please go back, at least do a mental check step. Make sure you didn't make a small error with your sign on the test. Okay, so when I first distributed, negative 2 times 2 became negative 4. Negative 2 times my minus 3 here became a positive 6. That's why then I subtracted my 6 on both sides. Negative 2 minus 6 became a negative 8. Okay, there's just a lot of negatives in there, so I would go back and do that check step just to make sure. Okay, let's try one more. This is the hardest one, right? If I see a minus 3 in front of my parentheses, I'm taking that whole thing to distribute to both my letters. Okay, the most common error is people will do 2 minus 3, solve this before they distribute, right? But if order operations, I'm supposed to multiply first. My very first step is to actually distribute. Okay, so this 2 gets to stay out here alone. My minus 3 times x becomes minus 3x. And my minus 3 times 1 would make minus 3. Okay, so again, I'm going to kind of put a box around there and maybe star it. That's the hardest question. Is when I'm going to distribute, it's only the thing that's directly in front of it. So I only distributed my negative 3 to both. My plus 2 stayed out there by itself. Okay. So my first step was I distributed. Second step, now we can combine like terms. So my minus 3x is a variable, but I can do 2 minus 3 to get negative 1. That equals 6x. Okay. I've distributed. I took them both times 3. I combined my numbers with numbers, combined my like terms. Now we can start things canceling on both sides. Since I already have the x on the right side with no number, let's go ahead and just get this x to the right side as well. Okay, there's no need to subtract 6x and then have my 6x with my minus 1 equal a 0, and then people get stuck and they're not sure where to go from there. Okay, so if I don't have any number over here, it's okay. We can get our x to the right side. The opposite of a minus 3 would be to plus 3x. So minus 3 and plus 3 would cancel. And I have minus 1 equals 9x. Okay. Last step, simply divide. So negative 1/9 equals x. It's okay to get a fraction. You can turn it into a decimal if you'd like as well, or you can just go ahead and leave it as negative 1/9. Okay. Just keep in mind, again, all the steps. I distributed, so I multiplied everything inside my parentheses first. Anything that was outside, though, needs to stay. I only multiply directly what's in front of my parentheses. Next step is to combine like terms. So if I have numbers, I can put with numbers, or letters with letters on the same side. Then I'm canceling on opposite sides. So I'm subtracting numbers from numbers, letters from letters. Final step is always I multiply or divide once I have just a number and just my variable on the other side.